So good afternoon, all. My name is Darshit Joshi, and I'm here to talk about and discuss the acoustical design requirement for today's green schools. Uh, the first question, the immediate question people would ask is that why is this required? And the response to that is because it improves increases the student performance. It reduces the absenteeism, and there is a better teacher retention. If I go in the numbers, the increased student performance goes up by 20%, and the teacher retention is reduced to 5%. So that's the reason that we are here to discuss. Again, my name is Darshit Joshi, and I have a background in mechanical engineering, my undergrad and graduation. And I have over 20 years of experience in acoustics, noise control, and environmental noise. I would have Andy introduce himself as well.
Thanks, Darshit. Hi, my name is Andy Carballero. Let me just turn my camera on to prove to you I'm a real person. I'm also a principal consultant over at ACENTECH in the ArcMech group. And in addition to serving as a principal, I also help to direct our innovation work. And part of that is to really establish a research-based practice with respect to classroom acoustics. So I'll tell you a little bit more about some of the research we've done and how it relates to our practice later on, but I'll pass it back to you, Darshit.
Thank you. So a little bit about the ACENTECH. ACENTECH is a 80-person firm with regional offices and multiple offices. We are an employee-owned company of acousticians, engineers, scientists, and technical consultants providing the services shown included on this page to clients across the globe. The ACENTECH traces back to its roots to the Bolt, Beranek, and Newman consulting firm, which was founded in early 1950s. So here's an abbreviated list of markets we serve. This is by no means a comprehensive list of things we do, which Andy would explain as we go into the presentation. But here's the markets that was more relevant to today's world. So we are a national firm, and we have a national presence with 4 main offices in Boston, Philadelphia, Charlottesville, and Los Angeles. And we have almost 8 to 10 regional offices shown in this map. So today's learning objectives is the review of acoustical standards in K through public plus independent schools and higher education institute. Once we go through the standards, there are 3 standards that we're going to discuss here. Once we go through that, we'll compare those acoustical standards, and then we would like to hear your questions and learn about your experiences. So this is the copyright material. So this is presentation is protected by the U.S. and international copyright laws. Reproduction, distribution, display, and use of the presentation without written permission of the speaker is prohibited.
All right, I think the way that we kind of worked this out between Darshit and I was that I would get to do kind of the easy stuff and some of the explanatory stuff, if you will, kind of set the stage, provide some vocabulary briefly, and kind of set the stage for the standards that we'll talk about. I'll also have a chance to tell you a bit about ANSI 12.6. That's it's the National Classroom Acoustics Standard. And my kind of time with you in this chunk will end a little bit when Darshit tells you about US chips and about LEED. What I was hoping to do, just as a kind of points of order, if I may, is one of the things that drives me nuts in a presentation is like having a nagging question and then having to wait till the end. So what I would ask is at the end of my little module here, if you will, the overview and the ANSI 12.6, if you have any questions that are really relevant to that material, please don't hold them. I'd be glad to kind of address a couple of quick questions like between the different modules. And then we've also saved time for questions and comments at the end. So if that sounds like a working plan to you all, I just want to again say thank you for inviting us. ACENTECH has been really, really lucky to work on a lot of great schools over the years. You see 6 schools that are shown on the screen right now, and I certainly won't tell you everything I know about all of them, but common features of them are that acoustics was central in all of them for different reasons. Sometimes in the context of assembly, for example, at Billerica, sometimes in the context of specific performing arts programs, as at Brooks, and sometimes in the context of highly inclusive and really kind of cutting edge school design, as you see at King Open School. So these are just kind of 6 places that we've been involved recently. And what we certainly see is that acoustics has taken on a greater and greater significance in design. Darshit started to talk about this a little bit. I thought his introduction was salient, and that is to say, this is very, very important in a societal way. Students are I'll actually spare you all the cliches about students being our future. You know those things to be true from operating architecture firms and being involved in our design disciplines. You know the importance of education to bring qualified candidates in that pipeline to our door. So learning, absolutely central to our society, and acoustics play a significant role in that. There's really 2 sides to that, right? There's students and there's teachers. There's learners and teachers, you might say. And both of those sides of the coin are immensely important to operating a school. What we know is that when there's poor acoustics, which we'll probably call too much noise and too much reverberation, there's 2 primary things that happen. First of all is that student performance goes way down. Student engagement goes way down. Student sense of belonging in the classroom, and particularly students who are hearing impaired, really, really suffers. At the same time, teachers become far less satisfied at work. That leads to burnout, high transition rates, turnover, and really kind of poor outcomes for teachers as well. One of the particular poor outcomes that has been shown to lead to teacher burnout is having to talk too loud. So always having to raise one's voice, leading to vocal fatigue and leading to general physiological strain. So acoustics are absolutely central to learning, and learning is central to our society. So in my business, there are a few things that are really as important as our work in classroom acoustics. Fortunately, I mentioned kind of a growing recognition of the importance of classroom acoustics. What you see is that there are at least 3 kind of standards, or what I might call design frameworks, that help us understand what the goals in schools might be. The first one that I'll get into a little bit more in a moment is called the ANSI S12.6 requirement for classroom acoustics. The next one we'll talk about is LEED for schools. I know everyone will be very familiar with LEED, particularly Darshit, as the case may be, as well as US chips. So these kind of 3 design schema, design frameworks that set goals for acoustics. And what I'd like to set the stage for is, what is the nature of these goals? What do they relate to? There's really kind of 4 key areas that these standards relate to. The first is reverberation and what you might call even more generally room acoustics. That is to say, what is the character of sound within a space? Is the space echoey or boomy? Is the space dry or very wet? Is the space live or dead? These are descriptors of kind of room acoustics, that they say what is the experience and the quality of sound within the space. As you would expect, as reverberation time goes up, as the room becomes boomier and echoier, it becomes harder for students to understand, and teachers tend to raise their voice, leading again to vocal fatigue. The same is true of exterior noise and HVAC background noise. We might just kind of clump them together for the sake of our discussion today. When noise is too high, that is to say by the HVAC system or transmitted from the outside, the effect is that everyone has to talk louder and listen harder. For students that have what is referred to as normal hearing, it's a somewhat pejorative term, but for students who have normal hearing, often these types of deficiencies of design can be kind of screened out cognitively. Said better, the brain is an amazing device. Its ability to filter noise and to find meaning within a noisy environment is really, really amazing. Certainly the brains of people that have cochlear implants are exactly the same as the brains of people who don't. What's different is that apparatus up front. And what we know is that students and learners who have hearing aids and cochlear implants, these things are very, very important to them. It is harder with those devices to filter out the adverse effects of noise and reverberation time. And so, because our general philosophy towards education is to not take these students and put them in a separated room, rather, our philosophy tends towards mainstreaming these students, having all learners together, not just being taught by the teacher, but also teaching each other. Um, this really kind of becomes a case for universal design for learning. That is to say, it would be great to have all different learners in the same room together. And in order to facilitate that, we might actually start to prioritize standards that address the most vulnerable portions of that population. So if it seems a little bit like I'm passionate about the topic and I think it's important, gosh, that's the main thing I'm trying to say so far. Some words that we're going to use. I was given some strict instruction from Darshit, who's an excellent designer and has a lot of experience in communicating with architects like yourselves. Please don't make this nerdy. Please don't make this a lot of math and nerdy technical concepts. This will be the worst of that. And what we're going to do is establish a language that I hope will be useful to you in your practice as you review materials, data sheets, as you work with acoustical consultants, and as you yourselves start to tackle some of the problems of classroom acoustics. Let's break these down into those same kind of categories we talked about before. They are room acoustics, sound isolation, and noise control. The three big terms we need to know here are the sound absorption coefficient, and this applies to a material. You could imagine a mirror hard surface. That would be an alpha of 1. It would be a sound reflector. It wouldn't absorb any sound energy. And you could imagine a very thick, fuzzy couch cushion, say 6 inches thick and of lush velour. That would be a perfect absorber, basically. It would have a sound absorption coefficient of about 1.0. You could interpret these as between 0% and 100%, presuming that there are no other fellow acoustical nerds in the room who can contradict me on that. There are some technical challenges there, but generally you could think of it as 0 to 100%. As you know, I can speak very, very high and speak at a low pitch, at a low frequency as measured in hertz. I could also speak very high up here at about 2000 hertz. I did that mostly to see if you were still paying attention. And so in this range from 250 hertz to 2000 hertz, the noise reduction coefficient is a single number value which says how absorptive is a material on average, where the sound absorption coefficient would be given at low pitches, high pitches, medium pitches. What you would find is that the noise reduction coefficient is an average of those values target at the speech communication range, 250 to 2000 hertz. Most of the data sheets that we will review, with you as architects in our role as acoustical consultant are expressed in terms of the NRC. All of these things are measured in laboratories and their properties of materials. You could contrast that with reverberation time. Reverberation time is the effect, or is the observable thing once you have a room of a given volume filled with surfaces that have a given sound absorption coefficient. So reverberation time, like we've already talked about, describes how long does it take for sound to decay to inaudibility, was the way it was originally framed in 1918 here in our fair city of Cambridge, Massachusetts. Another way to say it more technically is when we have a room and we fill it up with sound and we pull the plug on that sound source, how long does it take in seconds for that sound field to decay by 60 decibels? So those are all the things about how does sound behave within a room. We might take it out of the room. We might think about sound transmission and sound isolation. These will be certainly nothing new to any of the members of this call right now, but just by way of quick review, the STC ratings measured in a laboratory, they go and build a partition and they measure how much sound is on one side and how much sound gets to the other, and they quantify how good that partition is at blocking airborne sound. Similarly, impact insulation isn't about a speaker, isn't about a TV, isn't about a stereo. Rather, it's when I go put some hard-soled shoes on and I walk on a floor, how much sound is transmitted to the space below me? So these are two key descriptors of assemblies that go into saying, is it likely that students will hear noise disruption from the outside? And then finally, people tend to like air conditioning, heating, ventilating, and etc. And those things with them bring noise. And when we talk about noise created by ventilation systems and transmitted from the exterior, we think about rating it. I mentioned to you before that sound exists at multiple frequencies that we hear as multiple pitches, if you will, from about 20 hertz up to 20,000 hertz. The NC rating includes all of that information, and its goal is to say, hey, how noisy is this space? Members of ASHRAE and other kind of mechanical engineers who might be joining us, this will be a term very familiar to them. Indeed, this is the way that we kind of state our performance goals for room acoustics or for noise in many cases when we work with mechanical engineers. And I'll skip this one because I think I'm already running a little bit short on time and being overly verbose, but basically it's the average sound level. Would be glad to answer your questions about that after. So those are the ways that we'll talk about sound. We'll think about it in terms of room acoustics, sound within a space. We'll think about it in terms of sound isolation, transmitted to and from other spaces. And we'll think about it in terms of noise, both from ventilation systems and from the exterior. Um, True to my word, I'm just wondering, does anyone in the audience have any questions about kind of this background material before we start to apply it in the context of a standard?
Andy, just to ask for clarification, all of the criteria that you're listing, it's still voluntary code, right? And I mean, unless you're doing lead for schools where it's the prerequisite, but it's not required in any other basic building codes. As-
In Virginia, that's exactly my understanding, Joe. What you're going to see is that S12.6 is actually building code in the state of Connecticut and in no other state. And there's also some places that acoustics is creeping into the building code in a somewhat insidious way that I'll point out to you as we go through ANSI. Does that kind of address your question for now, Joe? Great. Any other kind of quick questions before we move on? I'm looking at the participants window and I'm not seeing any hands raised. Certainly, if you do, we'd be glad to see them in the chat or see your hand raised. All right, so we know what sound is. We don't even know how we're going to describe it. Let's go into a specific standard. There we go. ANSI S12.6 is the one that I know the most about, and Darshit has been gracious in allowing me to talk about it. What you would find is that the American National Standards Institute promulgates really voluntary standards, exactly to Joe's point. In many ways, ANSI says, what is a standard that another group might adopt? And they kind of create model language and code language, and with that, procedures and specifications for how that code might be implemented were it to be adopted. The only place where this is building code formally, as I mentioned, is in the state of Connecticut. What we will see about ANSI S12.6 is that it's kind of a model code from which the other sustainability frameworks have drawn their inspiration, much of which is research-driven inspiration. So there's another organization here that's near and dear to my heart, the ASA, the Acoustical Society of America. So ANSI and ASA working together in working groups have for the last 20 years developed this standard. It's something that we're terrifically proud of because it is a public-facing document. As I mentioned, this is law in Connecticut, but not really any place else. A recent development that I think members of the call will be curious to know about, and I fortunately Darshit has clarified some of this for me, is that in the 2017 ICC, there's a publication called A117.1, and it actually takes the acoustical requirements of ANSI and in section 808 creates a section called Enhanced Acoustics in Classroom Environments. And that A117, is sometimes adopted as part of the adoption cycle as states choose to as states renew their code, in that kind of a rolling adoption cycle. It's my understanding, and Darshit, I hope you will just jump in and tell me if I get this wrong, but I think in Virginia right now, this has been adopted with limited scope, and it currently applies to childcare facilities that provide care for between 5 and 100 people who are about 2.5 years of age on average. So believe it or not, acoustics are starting to come into the building code. Just in my opinion, the publication of this fact and the sharing of it with architects has perhaps been a bit lacking. Many people that I talk to across the country are not aware that in the coming years, we'll actually see some formalization of acoustics, and that would be, again, referenced to ANSI S12.6. The other bit of work that is really, really neat is that this is currently being revised. I have the opportunity to serve on this working group where we're using some research-based practice and some practice-based research to kind of make revisions to the standard that we think will keep costs appropriate for facilities while also facilitating that goal of universal design for learning, really having a great environment for all students and learners to hear. What you'll find is that ANSI creates these groups of space classifications, and for the sake of time, I certainly won't read these to you today, but what we have in ANSI is we have this idea of a core learning space, predominantly classrooms and spaces similar to classrooms. And we also have an auxiliary learning space, corridors, cafeteria, gymnasia, but certainly not spaces like a natatoria or a music performance space. When we say an auxiliary space, we're really talking about not a space where acoustics is critical. So as you look at the requirements of ANSI S12.6, they're kind of broken down as you see here. ANSI recognizes that as a room gets larger, as expressed by its volume in cubic feet, the criteria might reasonably change. And one of the things that you'll see as we go forward is that we're going to break down these criteria into basically noise and reverberation time. It is certainly true that sound isolation is an important part of this, but the most prominent features of these are to really achieve these two somewhat special criteria. Careful attention to partition design will generally result in performance near to the sound isolation goals. So about 0.6 seconds for a typically sized room, a bit longer for a medium-sized room. And as the room becomes very large, for example, the size of an auditorium, there's no longer a reverberation time goal. 35 dBA, about NC 30, for those of you that were thinking about the NC rating scale from before, that's very quiet. That is as quiet as most libraries. The thing that probably all architects and practitioners should know about 35 and 40 dBA, as required by all these standards, is that they are stringent. It's very quiet. It might be quieter than the mechanical engineers that we team up with are used to designing for. So one of the ways that we really, I think, bring value to a project team is by ensuring that these low levels of noise and reverberation are met. What you would also see is that as we talk about partition design, it really changes as a function of the adjacency. So as we consider a classroom or core learning space to another core learning space, an STC 50 wall would be appropriate. Quick review, that would be 2 layers of drywall on both sides of a 3 5/8 inch metal stud with bad insulation. An STC 45 wall would only be 3 layers on the same framing, and an STC 60 wall, as would be appropriate between music rooms, maybe loud spaces like mechanical equipment rooms, gyms, and the like, would be an STC 60 wall. That would be 2 layers of drywall on both sides, but 2 totally separate framing rows. So you would have 2 layers of rock, you'd have a framing row, you'd have a 1-inch gap, you'd have another framing row, you'd put insulation in that cavity, and then you'd put another 2 layers of gyp. So a massive partition. At the planning stage, whenever there's a project that requires STC ratings like this, at the planning stage, the critical thing to know is the width of these partitions and where is there a breakpoint. Whenever you talk about STC 55 and above, you're talking about a partition that tends to be wider than we're used to in normal applications. I'm going to skip a little bit of this and finally talk about the requirements for the facade. When we think about the facade, exterior noise is a significant source of noise within the classroom. And so ANSI S12, as well as the other standards Starship will tell you about, do contain criteria for noise transmission from the outside. This is an area that's a little bit more complicated and perhaps is more nerdy than some of the time that we have right now. So with that, I would love to know if you have any quick questions about ANSI S12. Otherwise, I would pass the baton back to my colleague, Darshit, to tell you about LEAD and US chips. Darshit, I think I basically just hear crickets, and that means that either I did a really good job or I put everyone to sleep. And in either case, I think the baton is yours.
No, it was wonderful. Thank you for doing that, Andy. Appreciate it. Lead for schools. So we'll talk about the Lead for Schools version 4. There are a lot of jurisdiction in Virginia that uses Lead for Schools, including the DC and some of the Maryland jurisdiction school systems as well. It is required. Lead for Schools version 4.0 is required in the state of Massachusetts for new construction and substantial renovation, but it is not a requirement in Virginia unless if the school decides to use this as a standard. The Lead for Schools is divided into 2 sections. One is the minimum acoustic performance that we all know as a prereq or a prerequisite, which is part of the the requirement for acoustics. The reverberation time that Andy explained, there are 2 options, option 1 and 2. And the first option, this is for the classrooms and core learning spaces defined earlier, which are less than 20,000 cubic feet. This option 1 is pretty standard. It just says that you consider the 100% ceiling for absorption, and the NRC of that tile or the acoustic panel that you use should be 0.7 or higher. This is the simplest. The 100% sealing would subtract the lights and diffusers and grills out of it, and the rest of it should be acoustically treated. Option 2 is that if you don't do option 1, you go with the option 2 and go with the calculation described in ANSI standard S12.6. I don't think that that's required if you go with option 1, which happens to be the easier of the two. The exterior noise, this is again a requirement which is missed in most of the schools that I have seen. This is a requirement for version 4.0. This was not a requirement for version 2009. So going into this is essentially what it says is that if you have high noise sites, if the school site is located in a high noise zone, you need to measure the peak hour. The peak hour LEQ should not exceed 60 dBA during the school hours. So the measurement is done inside the school during the school hours, and you take the peak hour, 1 hour LEQ for that entire stretch, which should not exceed 60 dBA, and then you apply the acoustic treatment for that. One of the requirement this requirement only applies if you are within 800 meters of the significant noise source, which is either you are close to airport or your highways, trains, industry. I've seen in some cases where they have done the exterior noise for the schools which did not apply, which did not follow this requirement because they thought that they were close enough to the noise source and it was impacting the interior of the school. So it's you are not required to do that if you are outside of 800 meters, but if you are within that, you are required to do that. The HVAC background noise is one of the, I would say that this is a little bit more complicated, and it in terms of budget, this one comes up on the top if we need to meet the 40 dBA. There was in the early 2017 when LEED for Schools version 4 was introduced, there was a lot of heartburn for the contractors to get down to 40 dBA because 2009 said 45 dBA, and then we dropped to 5 dBA. This is still not in line with the ANSI S12.6, which requires 35 dBA. So there is some economics that was put into thought when they came up with the standards. So we talked about the minimum acoustic performance. So those were the 3 parameters that we need to consider and execute in the minimum acoustical performance. For the LEED credit for LEED for Schools, version 4.1 allows you to go with 2 of the 3 parameters that I explained before, HVAC background noise, sound transmission, and or reverberation time. This comes up a lot. Now, if you meet all 3 of them, you get the exemplary performance point for that. So there is an extra point for that. But going for this credit will get you 1 point for LEED for Schools. If you go for the new PD plus C construction, it'll give you 1 point. And if you go for the interior commercial interiors, it'll give you 2 points. So this one comes up all the time. And we always say that if you want to start with it, and if you want to pick the 2, pick the best of the 2 of the 3, then reverberation time and sound transmission is the one that you should go with. HVAC background noise is hard to achieve, and it is expensive out of the 3. And then we need to provide the calculations to back it up. So there's, either it needs to be design documentation, those design documentations needs to be uploaded on the LEED website as well. In continuing with this, the standards that are used for HVAC background is the ASHRAE handbook, and they have a table in there. So the calculation procedure is there, and we follow that for the HVAC background. Sound isolation, we go with the table that is presented in the LEED. It's acoustic performance, and it's for AP credit. So you will find the table 1, and you will have to follow the SDC ratings. You will see here, notice here that the SDC has a small c as a suffix to it, a subscript, and this is composite SDC rating. So the other question that comes up is that if you have a wall it's an interior wall of a classroom or an office, and if you have a glass door or your glass wall, how would that STC rating equate to? And the simple answer to that is that we need to calculate the composite STC rating of all the materials incorporated in that wall, and we had to meet the STC ratings that is published in Table 1. So it becomes a little bit more complicated because if your wall, to get up to 50 or STC 55 is can be easy or difficult, but once you start putting the sound rated doors and sound rated glazing walls, that jacks up the cost of the project. Reverberation time, again, it's very simple. It's just you have to look at the table 2 that is given in the credit section of the lead for schools, and you have to meet those requirements. For US CHIPS, for those who don't know, CHIPS is the short form of the Collaborative Schools of High Performance, and this standard was first adopted in this area by Fairfax County, and it still uses the CHIPS standards. I have done a project with Loudoun County, and the Loudoun County also uses CHIPS criteria sometimes, but they also use the LEED. But the LEED certification, they don't do the certify their schools. They always do the LEED ready projects. So these are the two that I've heard in Northern Virginia. There are a couple of school systems in Southern Virginia or South, Central Virginia, which uses this CHIPS system. One of them is probably the Chesapeake Bay school system. So they use the CHIPS as well. 12 states have adopted this specific version of the CHIPS criteria. Until last year, we had the Virginia CHIPS, which has been replaced with the US CHIPS from this year. So if you go to the website, you would see that. The US CHIPS criteria 2.0, this is again, all the lingo and all the standards trickles down from NCS 12.6. Depending on, how economical they are trying to make their standards, they would use certain parts of NCS 12.6, and NCS 12.6 is still relevant because they would defer back to that standard in many cases for LEED as well as the CHIP standards. Here are the two categories. It's environmental quality PU15, which is a minimum acoustic performance. That's a requirement if you go with CHIPS, and C15 is the enhanced acoustical performance credit, which is optional. The amendments, general terms and definitions, you take from ANSI, as I say that, it comes from S12.6. The core learning spaces does not include the education rooms, libraries. So there is a little bit changes that are made in the CHIPS, which, if you go to the standards, you will find them. And these are the core learning spaces. The ancillary learning spaces does not include corridors. This is important because the corridors, most of the mechanical equipment go over the corridors. It goes on the roof, but it goes over the corridor. And CHIPS is one standard that helps you with that. So you don't need to meet the background noise requirement in the corridors. These are some of the categories that is defined here, like they have those acronyms that they use, what is required for that. I just wanted you to have a quick understanding of this, as in, you will see ICWS and SER mentioned a lot of times because these are the core learning spaces, and then you will have the other definitions of other rooms that will be explained in the standards as well. A few more in here, and we'll be using this PAS and all these acronyms in the tables of comparison when we do the comparison with LEED.
And that's exactly where we got to. Darshit, do you mind if I kind of try to summarize all the information that you just presented in 3 easy slides, or your money back?
Oh, absolutely. Yeah, unless if anybody has a question for the LEED and CHIP standards.
Oh, great point. Are there any questions on those 2 modules?
I think, hey, Andy, it's Camilo with the LR Group. I think my only question, really outside of, I think what you can all address, but is that the 40 decibels sort of background noise, or 35, You mentioned that it's quiet, and I think it's maybe similar to like having people whispering around you. And maybe I'm wrong, but it still feels like a significant amount of stimulation, right? That is kind of hard to have quiet in modern buildings.
I think you raise a really, really excellent point, which is that, and maybe if I could even try to take it a step further, which is that, yes, 35 dBA is quiet. It's certainly not silent, right? I would think of a whisper, if someone were whispering in my ear, that would be about, say, 50 dBA. If someone were to whisper at like 1 meter, that would probably be closer to about 35 dBA. So it is certainly fair to say that the HVAC needs to be designed to be whisper quiet, but not inaudible. And I think one of the points that Camilo made, I just want to maybe kind of second and strengthen a bit, which is that sound is still audible here, and that sound is much more important. That noise is much more impactful, to people that have cochlear implants, to people that are using hearing assistance systems. So while many of us can filter things out, there's a broad spectrum of learners and a broad spectrum of physiological performance. And it's certainly, to the extent that I have an advocacy platform here, I do advocate for that universal design framework of really letting all learners be in the same classroom. Camilo, I think I kind of got off on a tangent, but did I address your question
Yeah,
and
I think
comment? Do
you
you want to add
actually,
anything?
no, I think you addressed it exactly. That for some people, it's still impactful even when we're designing to quiet.
I think that's such a great point. Just maybe add one thing, because as you can tell, it's an area of passion for me. When we've had chances to work on schools for the deaf, we've worked on several cutting edge schools for the deaf. And one of the things that I learned there is that the term deaf is a hugely inclusive term, includes deaf community and deaf culture. And there are many people who are in the group of deaf culture and deaf community, who do have some physiological hearing that remains, and particularly for those people, having very low background noise and low reverberation really allowed them to get the most out of the physiological apparatus that they brought to the learning environment. So it's always, you can always be more stringent. Stringency probably carries more cost, but there are some applications where that is a reward that will pay society back tenfold, I would say. So I'll get off my society soapbox here and see if we can return to the numbers a bit here. We kind of talked about the three stools, if you will, of the three legs of the room acoustics stool, them being sound within the room, what I called room acoustics, sound brought into the room by background noise, so if, for example, from mechanical systems and from the outside, and then sound transmission between spaces. What you can see in this slide is that as we think about background noise, S12 is the most stringent. You would find, and kind of following up on Camilo's point, 35 is really pretty quiet. 40 is not really that quiet. Certainly it's perfectly fine for neurotypicals with normal hearing. It's near the upper limit of what I would design for. For example, in a corporate conference room, when there's a high ability to pay on the project, when the dollars per square foot are higher, 35 would be the upper limit. Certainly in a high performance space like a corporate conference room or something like that, where noise is very important and there's a greater budget, this is something that we spend a lot of time addressing. The other place that noise is so important is in the context of hybrid learning. That those hybrid learning devices, Zoom, such as we're on now, and microphones and hearing assistants, they really require quieter, drier rooms in order that all the learners kind of in the classroom and remote to the classroom can all be brought into that discussion. So one of the reasons that we see more of a premium on acoustics, more attention to acoustics, is the different modalities through which education is being delivered. As we think about room acoustics, much of the work that was done by NCS 12.6 has been carried forward in the other two standards, in LEAD for Schools and US CHIPS. Generally speaking, if you take option 1 for LEAD, you're going to get values which are very, very similar to about 0.6 seconds. A fun acoustics rule of fact is that if you put a highly sound absorptive ceiling, NRC 0.85 or better, over about 80, 90% of the ceiling, the vast majority of your room acoustics problems will in effect disappear. The ceiling is often one of the most convenient places to put a large area of absorption. That's why Lead for Schools took that very design-forward approach. Some neat work that we're doing, just to take a bit of a tangent in our working group, S12.6, is we're actually thinking about different ways that we might express the room acoustics. Here it's in terms of reverberation time. And I hope it doesn't sound pejorative to say that I don't know a ton of architects who could calculate the reverberation time. Indeed, that's why they would bring a team like ACENTECH to the overall design team. So reverberation time is not a very good design forward standard in the context of an architecture project. So one of the things we're considering is, might we take a framework more like LEED has taken in S12.6 in order that an architect, an engineer, and an AHJ ultimately could say, yes, we've met the standard, or no, we have not met the standard. Measuring reverberation time is non-trivial. Calculating reverberation time even more so. If we really want to get these things adopted, they have to be simple to adopt for designers and for the AHJ. So some interesting work going on in our working group right now, mostly to bring this standard into the future. And finally, kind of the third leg of that stool, if you will, was sound isolation. And as we saw, sound isolation requirements are a little bit hard to compare across the standards, across the design frameworks, just because they're so specific, right? But if we were to say in general, what are we looking for? If ACENTECH were just saying, what ought things be in broad brushstrokes, probably about STC 45 to a corridor, STC 50 to another classroom, for example. And if we have a noisy thing about STC 60, you would find that the requirements for LEED for Schools and US CHIPS, as you already saw, are very similar, and you would see kind of more detail in the tables that are cited. But in general, in broad brushstroke terms, the sound isolation requirements are very, very similar. Oh, we have a question from the audience, and it's even my colleague, Darshit. I see you have your hand up, my friend.
Yeah, it's not more of a question. Thank you, Andy. It's more of a note that I wanted to make here, that the last sentence that you would see for US chips, it says IIC requirements same as ANSI as 12.6. This is a very important sentence that is missed in the design. So when we are designing a major renovation in existing buildings for schools, we always come across the floor ceiling assemblies that are already existing and they don't meet the IIC requirements. For the architects, I would say that this is one important thing that we always point out in the beginning of the project, which is difficult to achieve. So this would require that your floor ceiling assembly is beefed up to get that IIC 50 requirement for that. So when you see a CHIPS project, and if it's an existing building, just immediately think about the IIC requirement to start with. Thank you, Andy.
I was really surprised that you had a question and instead you had a really helpful addition. Thank you, my friend. I see that we have 8 minutes left. One of my goals was to hear questions and to hear about experiences. And so what I'd like to do is actually not show you some of the pretty pictures that I brought with me and make sure that we have times for those questions. Some key takeaways before we do that, I think, again, like we saw, sustainable design and acoustical goals, really things that go together. We're talking about the quality, the overall environmental quality of the learning environment, especially on the mechanical equipment side, equipment selection, system design, and material choices, critical components of good acoustic performance. And then what we also see is that conflicts can arise between LEED credits and philosophies and other goals. Probably one of the best ways to address these conflicts and to navigate these waters, once you've really thought about them a lot in your own architecture practice, it's not to give a plug, but it is to say, gosh, we'd love to work with you on these things. And these are the kind of problems that we get up for, the ability to create better environments for learners across the board. That's a really cool thing to be involved in, and really grateful for your time today to get to talk about it. With that, I would love to know if you have any kind of bigger picture questions or comments, and just make sure I leave some space at the end here. Darshit, do you have any closing comments, or should we solicit the audience for their feedback?
Well, I would like to hear the feedback from the audience, but thank you, NOVA AIA CAE committee, for allowing us to present this, and we hope to have more of these in the future.
Thank you both. It's been an incredibly educational seminar presentation. I personally really appreciate you constantly mentioning the cost implications of some of these treatments. It really it really helps us understand that more, that some of these what the cost implications are for some of these projects if you're going to pursue some of these point systems, and what we need to be straight up with our clients about, or what we need to consider when we're budgeting the project. If anyone has a question, feel free to answer it. We can extend the meeting. If we take longer, that should be fine.
I got another quick one here. Darshad already talked about working with existing buildings and what to look out for. That's an excellent point. Projects that I'm working on, but what do you guys see typically that architects are doing in the creation of spaces that might be architecturally interesting but give you heartburn as acousticians, that you just wish we knew ahead of time? Doesn't mean we're going to change it, but we know at least that we're kind of causing that problem for ourselves.
Well, I would go first because I have a short answer to that. I believe that it depends on the project type. So, for example, if you're doing the performing arts, that would have a different complications and requirements from a school building. But if you stick to the school buildings, I would say that if you are working on an existing building, and if it's a major renovation, you definitely want to start looking at the standards. Now, we all know that the educational specs for all the public school systems, I mean, they supersede all of the standards that we have talked about. But there are certain jurisdictions that actually include the lead and chips in their education specifications. One thing that I would look for is anytime when you use the glass. That is one thing that comes up. That we need to look where you use the glass, because the sound isolation of the glass is not as good as the chipboard. Connections where the glass walls connect to the chipboard, or the chipboard connects to the concrete walls, the masonry walls. Those connections, there is a lot of flanking that happens, and there is a lot of quality issues that come up. So not in the design side, but just make sure that we have the details included in the drawings so that the contractor doesn't have an excuse to get away from it. So those are the few things. I would also say that some of the materials that are used, especially when I see the felt material that is being used for absorption, felt material, there are some of them are good and some of them are really bad. And so the selection of the material. So as soon as we select the material, as soon as we get into the project and help you select the materials and write specs for it, I mean, that would be one thing that I would encourage. And then bring structural. I mean, structure is like, as you guys know more than I do, structural design is so quick in the beginning of the project that it's already done, by the time we come in. And so we don't have a say on the structural design of the roof or the floors, where you have large AHUs and mechanical equipment placed. And so we would like to have that opinion about it. We need a little bit of flexibility on the structural and the mechanical design as well.
I think Darshad got the really good ones. I think I only have one to add there. I love this revolution that's happening with wood buildings, particularly in terms of CLT, and you're going to go build a gorgeous wood building. And what do you want to see when you look up? Acoustic ceiling tile. No, right? One of the reasons that we that we use wood in the first place is it's beautiful. We like to look at it. Some things about that wood, though, that are challenging from our perspective, it tends to be very sound reflecting. And because the ceiling is where we typically put our sound absorbing ceiling, exposing that wood leads to some challenges. There are really cool design solutions. One is to suspend things from the wood, perhaps baffles, slat systems, things that still allow the wood to shine but augment it. And another way to handle that is, Darshad mentioned selection of structure. As you select your CLT, there are actually CLTs that are made such that they can occlude sound absorption in these little gaps that go in between each of the boards from which the CLT is composed. It's a great reason to have us on board even if it's just a, a quick call before we're even officially on the project, having access to a project and just being able to kind of play with the big picture massing and big picture structural decisions can often have a lot of price implications after the fact. So being involved up front is the big thing that we like. But this CLT thing is definitely real. Everyone wants to see the wood, which means that you can usually see the mechanical equipment as well. So now you have not just maybe a reverberant environment, but you also have one where there's not even a barrier ceiling to go between, for example, a fan coil unit and the spaces served. It can be done, but it's a very, very quiet fan coil unit and or a fan coil unit that's been kind of relocated to the corridor and ducted. So there's a lot of great interplay between cutting edge sustainability and acoustics and overall learning outcomes. And it's just like so fun to be on that team, playing with all of those things. Up front is always better. What other questions or comments might you all have?
Andy, very, very helpful, Darshit. Really helpful, great content. Thank you. I'll only offer one comment really quickly. As buildings, there's more things that building needs to do, getting smarter, more requirements. We're getting pretty good as architects, I hope, at remembering rules of thumb, how much glazing, for a high performing building, solar orientation, going towards net zero, the classroom acoustics. Yeah, we all know we get a pretty decent ceiling, pretty much covered. Any other rules of thumb you can help us with as you work in this area is helpful. The places we struggle always are, cafeterias, gymnasiums, collaboration spaces. And so we're not going back later trying to change a design by adding acoustical panels on walls because we wanted some amount of open ceilings, et cetera. So if we're to your point, which is get you involved early. Sometimes we don't, but if we know we need to make space for what you do, I mean, at least in terms of products, that's helpful. It's a good reminder. If you keep it simple for us, we generally remember rules of thumb.
Yeah, I think I got one rule of thumb, which is the one I was trained on. It's still the one I tell myself every day. I guess there's two of them. There's the ABCs of acoustics, that, the three things that we have that we always consider: that we can absorb sound, like we talked about, we can block sound, and we can cover sound up. We didn't really talk much about covering sound up, as we might use like a masking system, as you would see at a commercial office environment. And that would raise the noise and make it harder for other learners. So the two things we have are to absorb and to block sound. So those are my kind of fundamentals, if you will. And the other way to think about an acoustics problem that I find to be really helpful for acoustics, mechanics, kind of physics generally, is this idea of the source, the path, and the receiver, and the different characteristics of all those things. Because that's really a way that you can take a complicated project, complicated problem, and break it down into these bite-sized nuggets that you can kind of operate on individually. So maybe, Camilo, to your point, what's a good thing that architects can do? Engage with the material. Don't be nervous about this material. If you take that source path receiver framework, you'll find that you have logical problems that your own design intuition can often solve. And if you want to just have a chat, that's really what we do at ACENTECH. We don't have a project until we have a contract. That doesn't mean we don't like to talk about this stuff. So you see Darshit and my email there. You see on our website our phone number. Please don't ever hesitate to reach out. We dig this stuff. And thank you for your kind words.
Yeah, and I also wanted to add one more thing is that, don't think that, we can't do anything with the source. We always have to work with the transmission path. We can always look at the source and we can try to, that is, from my, the first thing that I do is I always look at the source and try to mitigate it as much as possible so we don't have to spend money on transmission path. And the receiver is given, so there's not much you can do with it. But yeah, so the earlier we get into the project, we can do something with the sources. The later in the project, it becomes difficult and yeah, impossible.
And that's exactly what we see, is that given the lead time for mechanical equipment, often the chiller that we're going to have to make quiet has been bought a year before we're even bought onto the project, just because the lead times are so long that often the owner is pre-purchasing equipment alongside the design team being onboarded. So sometimes we have existing conditions and constraints, and that's what makes for good design, is how you work within those constraints. Within reason, of course. Please don't give us very loud chillers.
Yeah, and I would like to add the last thing that, these are the standards that we use, we typically see in this area, but there are also other standards that are popping up in this area. I mean, I want to mention IGCC is one of the standards that a lot of Maryland public school systems, they are using IGCC, which is different from these standards. We also have the WELL version 2, which is again different, and it gets you almost 18 credits for the sound category. So there are more standards. There is a Virginia Department of Education. They have their own sound requirements. So there are a bunch of sound requirements that you need to address once you are, depending on what type of project you have and where you're located.
Thank you, Darcy and Andy. Again, incredibly educational presentation, and thank you for your time.
Yeah,
Have a nice
thank
rest
you
of
for
your
having
day.
us.
All right.
Right.
Take care.
Thank you all.
Thanks.
Thank you all. Take care.
Thanks again.
Thank you. Take care.